Assalamu alaikum, ladies and gentlemen, welcome back to another video. So in this video I want to show you how I got ffmpeg-next working in Rust. So ffmpeg is basically a library that helps you decode and encode like videos and even audio, right? And so if you want to use it in Rust, you have to use ffmpeg-next. Though turns out it's not easy as adding it to the dependencies in your cargo.toml as most Rust libraries are, because well, this is depending on the ffmpeg binaries that are written in C basically. So yeah, all right, so you just add ffmpeg-next to your dependencies. Here I'm using version 7.1.0, which also coincides with the 7.1.0 ffmpeg version. Cool. Now the next thing that you're gonna need is a couple of things. First, you gotta make sure that you have like the ffmpeg build installed in your computer. So like you're just gonna search for ffmpeg pretty much, well, without Rust, just ffmpeg alone, right? And then you go to ffmpeg page, and let's go to download page. And then in my case it's Windows, so I'm gonna come here and either this or this, doesn't matter. I'm gonna go with the first one. And then you're gonna go down into release builds, and you're gonna get this ffmpeg release full shared 7z, save, and then you gotta get it installed on your computer basically, just like that. You're gonna open it up, you're gonna extract it, extract all, extract, or use 7-zip or WinRAR or whatever other like executable that can help you do that, right? Alright, so here we got this folder right here, which contains bin, doc, include, library, and presets. Now we need some way to tell ffmpeg-next crate or library where our ffmpeg stuff exists in, and we do that through some like environment variables. So you're gonna need, like, I realized how to do that through, like, if you look into ffmpeg-next here, right, and you go to their page, you're gonna look for build instructions here. There we go. And you're gonna find in some instructions for Windows, right? So let's see. So you're just gonna set ffmpeg-dir to the directory containing include and lib, which is basically this directory. So what you're gonna do, you're gonna copy this, this folder, this whole thing, Control A to select the whole path, and then Control C to copy it. And then you're gonna look for that thing, right? So, sorry, environment variables. There we go. Environment variables. Then you're gonna find the ffmpeg-dir here, okay? So actually you're just gonna say new, right? And then you're gonna make sure that the name exactly matches, like, with everything, and then paste in the value here, and then you just say okay. For me, I already added that. The next thing that we're gonna need is a libclang path environment variable, and this is the path that you're gonna find it in. Let me show you how to find it myself. So you're gonna go to this PC, local disk C, program, files, and then Microsoft Visual Studio 2022, community, VC, tools, and LLVM. Though you may not find LLVM, it depends on your setup. If you don't find LLVM here, then look for Visual Studio Installer, or install it through the web. So just look for Visual Studio Installer, download Visual Studio Tools, and then click on free download here, community, and then you're gonna have the installer. Okay, so if you don't have Visual Studio Community already in, then you have to install it. Otherwise, if you already have it installed, then you gotta say modify. Okay, and then go to individual components, look for clang. Okay, and then check out this thing, right? Check out the C++ clang compiler for Windows, and then click on install, and then it will get installed. It will take some time depending on your network and so on. But once that's done, you're gonna find LLVM here. Sorry, not here, here, right? So you're gonna find LLVM, then you're gonna go inside. Now it's very important to go to this x64 folder, right? And there we go. Now you can find the bin and the lib of clang x64. Now I'm just gonna copy this path again here, and you're gonna come here, and in this that environment variable libclang path, you're gonna paste it in here, okay? After that is done, make sure to actually, like, after you edit the environment variable, make sure to exit Visual Studio Code and like open it again, because if you don't, then the newer environment variables won't be visible to Visual Studio Code, okay? So make sure to do that. And then afterwards, you need one extra step, which is to grab, like, to go back to that folder of the binaries, of FFmpeg binaries. There we go, okay. So you're gonna go to bin here, right? And then you're gonna copy all of these. So like you're gonna hold shift and click on the first item and like click on the last item, right? And then you're just gonna hold control and click on these ones because we don't need them. These are command line tools, not libraries, right? And then you're gonna copy, control C, and then you're gonna come here, open or like reveal in File Explorer, right? And you gotta basically control V to paste them into the root directory if you're a Rust project. After that, finally, congratulations, you should be good to go. This should work out just fine. So the code that I have here is actually from the examples, and I invite you to look up the examples too. So if you go to back to here, right, to Rust FFmpeg GitHub repo, you're gonna find all the links down in the description below. And you're gonna go to examples pretty much, and then you're gonna find multiple examples. Remux, this is an example to take one, like a video from one file format to another, or an audio, doesn't matter. But basically any media from one format to another. Well, just the container format, because there's the container format and the encoder format. But let's not get into much details. You can, you know, search, look it up basically. But basically there's two kinds of formats. Alright, there's also transcoding audio, metadata to get the metadata of the media, and then here dump frames and codec info and chapters. So this is the one that I'm using right now. You're just gonna go ahead, copy this whole thing and paste it here, right? And now also make sure to add output slash frame.ppm here, right? Otherwise it would flood your main project folder with images. And you're just gonna create a folder called output, and then you're gonna run this code. So cargo R, and then you're gonna say sample.mp4. Notice here I have a video file in the root directory of my project called sample.mp4, which is just a little sample from the internet pretty much, right? So if you actually run this, you gotta wait a bit. So right now what it's doing, it's basically going through that whole video, decoding every frame and converting it into an image file of type ppm, pretty much. And yeah, there we go, it's done now. If you look up now the output, you're gonna find all the frames of your video. There we go, all the frames, like for example this frame, let's say. And of course, if you want to check out the ppm format, which is just a simple image format, if you want to check it out, you gotta look for, you gotta install an extension called, yeah, there we go, ppm pgm viewer for Visual Studio Code. Though it's gonna take a while to actually open that file, because it's not very, you know, efficient file format. It's just that this code example is using it because it's pretty, you know, simple to make a writer for it, or it's like a saver for it. But anyways, let's see if we can decode this file. Let's see. And it's actually taking quite a while though. Maybe we could find some viewer in the internet that would be better. Maybe, let's see, ppm viewer. Oh, there you go. Okay, so it took a while because the image is quite big. But there you go, we got the actual frames of the video right now. And of course this folder is probably huge right now because like it's the whole incompressed images of the whole video, right? So if I actually go to, where is it? Reveal in File Explorer, then I actually see the properties. Oh my god, look at that, 4.79 gigabyte. But yeah, so that's basically how it works. I'm just gonna remove that output because I don't need it. Just taking up a lot of space. But yeah, that's pretty much it. I think I'm gonna go through this code and maybe show you what's happening here. So here we're basically initializing FFmpeg, right? So if you actually hold control and click on here, you're gonna look into that. It's initializing some errors, initializing the format, initializing the device, and the filter libraries of FFmpeg. Now here we're basically opening an input context, right, using the first argument of the command line, otherwise we say cannot open file. Then here in the input we go through all the streams in the video, because well, all videos or all medias have multiple streams. Like you could have a stream of video, a stream of audio, a stream of subtitles, etc. And then here it's basically looking for the best stream of type video, right? Because you could have multiple streams of video for whichever reason. Otherwise we return an error. And then we have video stream index. So we get the video stream index. Okay, then we create a decoder from the input stream parameters. So basically a decoder that is, you know, like compatible with that input parameters. There we go. Here we got the decoder. Cool. Then we create a scaler, and that would help us like convert formats and so on, and you know, scale the image frames, etc. So here we're passing in the decoder format, the decoder width, decoder height, etc. So basically the decoder is getting its format stuff, like its width, height, format from the video stream parameters that we have picked. And that's basically it. Of course bilinear, because you could make scaling operations using this scalar object. Now we have frame index, okay, and here we just have a closure called receive and process decoded frames. It basically takes a decoder, then returns a result. So basically here we have an empty video, or basically, yeah, empty video, right? And then here we go through every single frame. So we have a while loop, every single frame, and then we basically add it to the decoded video. Now, if that's okay, then we basically create a new RGB frame, and then we run the scaler on it to convert it into a simple RGB frame, because the decoded like image from the video, or the decoded frame from the video, would be in a particular format that is not very readable. So we use the scaler here to actually convert it into a RGB frame, and then we use our file here, like our function here, to save that RGB frame into an actual file, ppm image, right? And then of course frame index plus equal 1, okay. And here we use, I think, the index, yeah, we just use it to name the images, pretty much, name frames. And yeah, so here we got for every stream and packet, in the context packets, stream index. So if it's the video stream index, then we send the packet to the decoder. And then here we actually use this kind of, you know, closure that we made, right? So here we basically go through all the packets in the video file. If the packets are from the video stream that we have picked here, right? That we have picked, like the best video stream that we have picked, then we send that packet to the decoder that we have made, right? And then we use our closure here. And yeah, and after that we just say send AF, meaning we're done with the operation because there's no other packets left. And finally we process the last frame there, and there we go, done. So yeah, if you want me to go through like in depth on the other examples, let me know down in the description, but for now I think it's time to say goodbye. If you have any other suggestions for future videos, please let me know. If you have any questions, please let me know down in the comment section. So yeah, that was it guys for this video, and see you later. Goodbye everyone.